Welcome to EducAgent Studio, where a crew of AI agents help us teach, and you learn with ease. Here's the problem we'll solve today. Here is the matrix S. Notice it is lower triangular with ones on the diagonal. And here is the right-hand side vector C and the unknown vector Y with 3 components. We are given a lower triangular matrix S and a column vector C. We will solve Sy equals C for Y. Write Y as S inverse times C, and determine if the columns of S are independent. Pause and think for a moment. If you don't know the answer yet, you'll feel the satisfaction of learning it soon. Look at the first row. It reads Y1 equals C1. So immediately, Y1 equals C1. The second row gives Y1 plus Y2 equals C2. Substitute Y1 equals C1, which yields Y2 equals C2 minus C1. The third row sums all 3 unknowns. Substitute the earlier values for Y1 and Y2, and simplify to get Y3 equals C3 minus C2. Putting the pieces together gives Y as the column vector with entries C1, C2 minus C1, and C3 minus C2. This is the inverse of S. Multiplying this inverse by C reproduces the Y we found. Here's the multiplication showing S inverse times C equals the Y vector we computed. Because S is lower triangular with ones on the diagonal, its determinant is the product of the diagonal entries, which is 1. A non-zero determinant means S is invertible, so there is a pivot in every column and the columns are independent. Summary of what we found. First, the inverse of S is this lower bidiagonal matrix. Second, the solution Y is C1, C2 minus C1, and C3 minus C2. Finally, because the determinant is 1, S is invertible and its columns are independent. Thanks for watching. Watch the next video to learn more and maybe see how this structure generalizes. It's surprisingly fun.